Hello ladies and gentlemen, welcome to my video. This is today's question, consists of summation for k, integral for dx, and limits for n's. It looks so difficult, but the fact is, it is quite easy. We just have to solve the summation first, and then integral, and then limits. All the terms has been arranged nicely. There is no need to do any interchange. First, focus on summation. Define s equals to summation k equals to 0 to infinity. Numerator is k multiply k minus 1 multiply cosine n power k, while the denominator is k factorial, where k is a constant that eventually goes to 1 or equals to 1. For simplicity, we define y equals to cosine n, and therefore y power k equals to cosine n power k. And then we update equation s. Let's see Taylor series for e power y, which is equals to 1 plus y power 2 divided by 2 factorial plus y power 3 divided by 3 factorial, and so on. Or e power y equals to summation for k equals to 0 until infinity, y power k divided by k factorial. The right hand side of this equation is similar to s but missing something. So what do? Apply differentiation over dy for both sides. Differentiate e power y over dy is still e power y. For the right hand side, differentiate y power k over dy is equals to k multiply y power k minus 1. Compare this with the s. We still missing something, which is k minus 1. So we differentiate again both sides over dy. The left hand side is still e power y, while for the right hand side we have an additional multiply k minus 1 and then y power k minus 2. Almost there. Let's multiply y power 2 to the both sides. This means the right hand side y power k minus 2 become y power k. Now we solve s without summation of k and so on, which is s equals to y power 2 e power y, or cosine square n multiply e power cosine n. Put the s we found back to original question q. This is q with the letters s we found just now. We can rewrite q equals to limits n goes to 1, cosine square n multiply e power cosine n, and then integral negative 1 to 1 n power x dx. Label the integration part as j. I think we can solve j easily, which is equals to n power x divided by natural log n for x equals to negative 1 and x equals to 1. Putting x equals to 1 and negative 1, we have 1 over natural log n minus 1 over n multiply natural log n, which is equals to n squared minus 1 divided by n natural log n. Put the j we found just now back to q. Q become limit n goes to 1, cosine square n e power cosine n, and then n squared minus 1 divided by n natural log n. Cosine square n and e power cosine n's are just constant number when we replace n equals to 1. So therefore we can further simplify q become cosine square 1 multiply e power cosine 1 multiply limits n goes to 1 for n squared minus 1 divided by n natural log n. Let's focus on the last part, which is L. Obviously, L is equals to 0 divided by 0. Apply L'Hopital-Rules, L become limits n goes to 1, 2n divided by natural log n plus 1, which is equals to 2. Now, put the L back to Q. That brings us to the conclusion of this video. The final answer of this question is 2 multiply cosine square 1 multiply e power cosine 1, which is approximately equals to 1.0022. Thank you for watching this video until the end. Please continue support my channel, subscribe, give a like and share my video with others. See you tomorrow for new video. Bye bye.